Hello, and thank you for your invitation to the first virtual conference on structural integrity. The title of this presentation is a fracture mechanism in human teeth. We will discuss in this work the cracking phenomena and its simulation or first simulation using for the first time fracture analysis code Frank 2D. Objectives: we will show why teeth splitting and why we did use fracture mechanics approach to simulate the crack growth. In this case study, we had to use finite element analysis software. Then we will show the fracture mechanism in human teeth and the assumptions we had to assume in this approach as based on finite element analysis. Also, finite element model and boundary conditions. Then results, the benchmarking and the comparison with literature and previous studies. Finally, conclusions. Objectives: actually, previous studies mentioned that little literature are existed on the cracked tooth, and for sure, little studies trying to simulate the crack growth in teeth. As based on fracture scenario, material cracking is a first step of the teeth splitting. Why splitting? Because enamel is very brittle and having a low fracture toughness. Therefore, the crack propagates from enamel toward the dentin, then toward the dentin-enamel junction. This line or this margin will resist the crack propagation. Hence, the simulations give an insight for repairing. Fracture mechanics approach help us to follow the crack propagation and direction in the body. Also, this approach, as shown in previous studies, give us an accurate stress intensity factor calculation or accurate values of fracture toughness. These items will help us to find a suitable design, determine the safety load, and select the suitable material, and vice versa. That means the three parts below will enhance the fracture toughness. As mentioned before, fracture mechanics approach was successfully used in different applications, like in airplane design, bridges, and in biomechanics approach in teeth implants, and fracture in hip. Fracture analysis code or finite element analysis software Frank 2D was used in this simulation. Frank 2D is a finite element based simulator for crack propagation, and CASCA is a preprocessor for generating initial input file for Frank 2D. We published different works using this software in rock mechanics and forwarded joints. The output of this program to find stress intensity factor or fracture toughness and the energy released from the crack propagation. That means this program was verified and has some advantages as compared with other finite element analysis, such as a quick mesh generator, no big effect of mesh size or the mesh density distributions. Here we can find some models and some case studies using Frank 2D. The simulation of cracks between two holes in airplane fuselage. That means the simulation for metals or the simulation for non-metals like in dams or rock mechanics. The human teeth has four main parts. The first part, enamel, is the outer layer of the tooth and the hardest material in the body. It's even harder than the bone. Therefore, and because it's mostly brittle, we can apply the linear elastic fracture mechanics approach. Then we have dentin, the inner layer and the main part of the tooth. Then we have bulb, and finally the root. The teeth splitting occur in vertical direction. However, the combination between horizontal and vertical flows may also appear. Traditionally, the cracked tooth refers to vertical defect that may extended longitudinally, reaching the root. By the effect of cyclic loading, like chewing, and the presence of these cracks, the splitting will be extended. As shown in this figure, we have the distributed normal load over the crown, and we have also the cracked tooth. Then we will have a biaxial effect over the body of the teeth. We can now summarize the main factor that causing the fracture in human teeth, such as thermal fatigue, cyclic loading, the presence of microcracks, and aging, and as shown in these two figures. As mentioned before, the linear elastic fracture mechanics approach, as based on some assumptions, was used in this work. Like in bone, most studies evaluate the fracture toughness of dentin using linear elastic fracture mechanics approach, hence ignoring the plastic deformation, or in other words, the plasticity effect over the crack tip was neglected. Therefore, the crack propagation will be under elastic properties. Another assumption, the material is anisotropic. Actually, the plasticity effect was estimated due to the collagen content in dentin, and this plasticity will enhance the fracture toughness. Therefore, some studies considered or used the elastic plastic fracture mechanics to evaluate the fracture toughness in human dentin. Nevertheless, linear elastic analysis was proposed also in other studies. This slide will show the finite element model and the boundary conditions using Frank 2D. The constant distributed load was used over the crown. Fixity on the root, we had to subdivide the geometry for different parts and selecting the mesh for each part. Different type of meshes were used for single model. Results and benchmarking. The results are compared with the literature. The crack path has been simulated successfully using Frank 2D as based on linear elastic fracture mechanics approach. The crack initiates from the notches toward the high stress region. That means the crack will start from enamel or over the crown. Conclusions. The crack is a common phenomenon in human teeth, and the crack resistance decreases at the aged teeth. Second, the crack starts from the high stress notches due to the distributed load over the crown. Also, the linear elastic fracture mechanics can simulate the teeth fracture, and the corresponding treatment can be estimated according to the crack path simulation. And finally, Frank 2D shows the ability for this simulation, and the crack path was compared with literature, and this comparison is well defined. Finally, we have to mention that everything is material and should avoid the fracture. Thank you.